This is video 2 of looking at problems that are related to the binomial theorem. And in this particular problem, I do want you to notice that this, I'm calling it example 1, but it's example 48C on page 59 in your book. And as a suggestion, you might want to try examples 48A and B on your own. And you might even try them first and then check to see what the book has done, just to see if you've done them correctly. But in this particular problem, they're giving us a binomial, 2 plus ax, the quantity 2 plus ax. We're raising it to the 7th power. And you'll notice that they've started the expansion. They've written the first few terms of the expansion. And what we're supposed to do is find the values of a, b, and c. So I think what we'll do is we'll start by writing, using the binomial theorem that we have up here, the summation notation, and writing our binomial expansion as a summation. So notice in this problem that the value of n is 7. That's the binomial power. And so we're going to be subbing 7 in for n in each of these places. And so we're going to end up with the sum for r equals 0 to 7 of 7 choose r. And then a, now a, remember, is the first term. And our first term is 2. So we're going to have 2 to the 7 minus r times b, and notice that b is the second term, which is ax. So we're going to get times ax to the r. So you can verify that that matches. And they've done 4 terms, 1, 2, 3, 4. So why don't we also expand out 4 terms? So the first term will be, of course, I'm going to move this over just a little bit to make sure that I have room for this. The first term will be 7 choose 0 times 2 to the 7 minus 0, which is just 7, times ax to the 0. The next term will be, so remember, we're starting with r equals 0, and then we're adding 1 each time. So now r is 1. So we'll have 7 choose 1 times 2 to the 7 minus 1, which is 6, times ax to the first, plus 7 choose 2. Now r goes up by 1 again. So 7 choose 2 times 2 to the 7 minus 2, which is 5, times ax squared, plus, and then we'll do one more. So the next one, r is now 3, so 7 choose 3 times 2 to the 7 minus 3, which is 4, times the quantity ax cubed. And then it'll just continue on like that for the remainder of the terms. So now if we simplify this, and I'll let you kind of verify this with your own calculator, with your own calculations, but 7 choose 1 is just 1, 2 to the 7th, and then this to the 0 power is also just 1, and 2 to the 7th is 128. Plus, over here, 7 choose 1 is 7. Again, you can verify these on your own. 2 to the 6 is 64, and then we have ax to the first, so those will just be to the first. So we end up with 7 times 64 is 448, and then we have ax, plus 7 choose 2 is 21, and 2 to the 5th is 32. And then we're going to square each of these because we've got that product squared. So 21 times 32 is 672, and then we'll have a squared x squared, plus, and then 7 choose 3 is 35, 2 to the 4th is 16, and then we're cubing this product, so we have to cube each of the factors. So 35 times 16 gives us 560, and then we have a cubed x cubed. Okay, and then it just continues on. So again, I'll let you kind of verify that. So what I want you to notice is that these terms should match up. So we can see, for instance, right here, that this is the x term, 48ax, and then here's the x term right here. And then we can kind of see how the rest of them match. Here's the x squared term, here's the x squared term here. Here is the x cubed term, and that should match with the x cubed term here. I should have used a different color. And then here's the constant term, and that should match with the constant term here. So we can just kind of start by setting some of those equal to each other. We're supposed to find a, b, and c. So we can see that 128 has to equal b. So therefore, b is equal to 128. So we have one of the values that we need. We might notice the next one, that this coefficient, 448a, has to equal 224. In other words, 448a times x has to equal 224x, And we're not really dividing by x, but we're just noting, hey, these coefficients have to be the same. So 448a has to equal 224. And if you divide both sides by 448, you'll notice that a is equal to 1/2. So we're doing pretty well. The next one, the purple ones, we can see that this has to equal this. So we can say that 672a squared x squared has to equal cx squared. And remember, we just figured out what a is. A is 1/2. So if we substitute that in, we get 1/4. So we get 672 times 1/4 x squared has to equal cx squared. And 672 times 1/4 is 168. So we get 168 x squared is equal to cx squared. And again, we're not really dividing by x squared. We're just noting, hey, the coefficients have to be equal. So we can say, therefore, c has to equal 168. And we will stop with this example, and we'll do different videos for the other.